Hey guys, let's take a look at lesson 48. These are radicals. Before we do this, let's actually look at an oldie. And if you remember how to do these, we won't do the entire thing, but remember how to do these. You will take this and go, okay, well, the way we write this is to go, okay, that's the square root of 2 over the square root of 3. Then we rationalize it by doing this. And then we go, okay, that's the square root of 6 over 3. Got that part. And you go to this one and go, okay, the square root of 3 over the square root of 2, rationalize it again, and that gives us the square root of 6 over 2, and then we take this, and we take that, and we find a common denominator, then we add them together, and then boom, you got it, right? Okay, we're going to do that today as part of what we do. All we're doing on this type we're doing is adding a third one, and what they've done is they've contrived these problems so they work perfectly to fit in with, you know, the kinds of denominators that you already have. So let's look at the first one. If you want to take a second and pause and copy this down. Okay, we'll take this one and go, okay, this is going to be 3. Then we got the square root of 5 over the square root of 2. Then we rationalize that by doing 2 it again. Then we'll take this one. We got plus 3 times the square root of 2 over the square root of 5. And then we go, the times the square root of 5 over the square root of 5. We'll come to the 90 in a sec. You know what, let's just do the 90 now. What the heck? Okay, 90, you should look at this and go, okay, I'm looking for 2 factors of 90, one of which is a perfect square. So you go, I got it. That's going to be 9 times 10. You take that out and go, okay, the square root of 9 is 3, and then boom, I got it. So my answer is 3 times the square root of 10. Okay, now if you recognize the square root of 10, if you look at it, you can tell that's related to this 5 and the 2 already. You see what's happening here? Okay. So this one, let's do this one first. This turns into 3 times the square root of 10 over 2. This one turns into 3 times the square root of 10 over 5. This one is 3 times the square root of 10. We'll just put it over 1 just for the heck of it, okay? So we recognize our common denominator. We're going to have to take this and go, okay, well, this is going to be 10, obviously, okay? So we multiply by 5, which means we multiply that by 5 as well. We multiply by 2, which means you multiply that by 2. You multiply this by 10, which means you take this by 10, okay? So this one, 5 times 3, 15 square root of 10 over 10. This one, 6 square root of 10 over 10. The last one, 30 square root of 10 over 10. All right, since these are all common denominators, we're just going to go 15. Of course, these are like terms as well. Don't forget, there's a square root of 10, there's a square root of 10, there's a square root of 10. So we got 15, we got 6, excuse me, and 30. So that gives us 21, 51. Let's do it all at once. 51 square root of 10 over 10. And look at this number and that number. Can you reduce it? No. Good enough. That is our answer. Okay, we did exactly the same thing as we did on the old ones. We just added one type right here that they always contrive it so where it kind of matches up. Okay, let's try another one. All right. So pause and copy if you need to. All right, so we'll take the top one, or the left one, and go 3 square root of 2 over square root of 7, and of course, square root of 7, square root of 7, plus 5 square root of 7 over square root of 2, and then square root of 2, square root of 2, plus 3 times 56, blech. Okay. If you don't know what else to do, if you go 56, I can't figure out what's going on. 8 times 7, I know, but how do I, you know, whatever. Don't worry about it. Just take 56, go over here and go 56, okay? 8 times 7, well, that's prime. 8, let's see, 4 times, 2, that's prime. And then 4, 2 times 2, all right. So underneath the radical, in other words, here, you've got 2, 2, 2, and 7, okay? So what you can do is you can go, okay, that's going to be a 4. I'll pull that out, right? And that turns into a 2 out here. Then I have 2 and 7 left under the radical. Yeah, nothing you can do about that. So I've got 3 times 2 outside here. We'll just call that a 6 and square root of 14. Now if you notice, there's a 7 here and a 2 here. We're going to have another 14. Okay, so let's take a look at these. We got 3 square root of 14 over 7. We got plus 5 square root of 14 over 2. And we have 6 square root of 14, we'll call it over 1. All right. And we'll do our same old rigmarole here, right? We'll do times 2 to give us a 14, because we want 14 as our common denominator. This is 7 times 2. That's 7 times 5. This is going to be 14 times 1, so 14 times 6. Okay. Now we have 3 like terms in the denominators, right? Everything's square root of 14. So 2 times 3 is going to be 6. 7 times 5, 35. 14 times, good gravy, 84. Okay, so what is that? Good night. 41 plus, oh my word, 125. Okay, so it's 125 times the square root of 14 over 14. Now, can you knock this down, reduce it a little bit? You might look at the 14s and think you can, but you can't. That's a square root. This isn't. So nothing you can do. That's as good as, there you go. And again, all we've done is add one extra thing that kind of always figures in there and works perfectly when you look at the numbers. Okay. All right. This part of the lesson is kind of weird. Okay, so I'll just tell you that at the beginning. All right. But once you have it's like arithmetic. Once you know how to do long division, you can go, okay, I'll do the same thing for algebra. Once you do fractions with 3/4 plus 5/8 or whatever, you do that for algebra as well. It's the same thing. We already know. Look at A, B, and C. Look at those. You know the answers to those, right? Let's do them together. Okay. This, what's the answer to that? X to the what? 13th, right? Okay. This one's different, right? It's going to be x to the what power? Remember, a power to a power, you multiply, so that's 40, right? Okay. This is kind of the same as B, but with a little twist to it with the fractions, right? But you know what to do, right? Still the same thing, right? Okay, you still multiply fractions, right? So what is 1/2 times 3/4? It's 3/8, right? Okay, everybody there? Okay, you know how to do this, all right? Now, once it gets to be kind of freaky looking, all you need to do is take the weird looking radical things, I'll call them, and turn them into, terms like this. Then you can piddle around with them a lot more easily, okay? I mean, it seems like half the stuff we do in Algebra 2 is just take stuff that looks new and weird and do a couple of little steps and turn it into something we've done before, which we know how to do, and then we got it, okay? All right, you'll get the hang of these pretty well, okay? Look at this. Rewrite these as numbers with exponents. Now, look at this first one. There are 2 numbers missing in this that you could stick in there. They're not there, but you instinctively already know that they're there, right? Well, first off, that's the square root of 3, right? We don't have a number right there, but we know it's a 2. We understand it's a 2, right? There's nothing, okay? By the way, 3 is 3 to the what power? To the first, right? Boom, okay? So what we do is rewrite 3, it'd be 3, and if you remember, this is to the 1/2 power. Remember that? Okay, the number inside the radical goes on top. This one goes on the bottom of the fraction, okay? This one here, remember that? That'll be 2 to the what power? 3/5, right? Okay. You remember those. Okay. All we're going to do is kind of mash these types with these types. And you'll see what happens here in a second. Okay. One last thing. Let's do this. You know how to do all these. Okay, so let's do them. What is a to the 7th times a to the 3rd power? What is it? A to the what? -4th. Okay. How about this one? Y to the 4th brought to the -9 power is y to the -49th, but no, don't. Okay, yes, -36 power. Okay, all right. And here's a weird one. R to the 5/8 brought to the 2/3 is r to the, and you can do 10, then you can do over 20, that's a 10, over 24. You can reduce that to 5 over 12 if you want. So in other words, r to the 5/12th power. There you go. Okay. You there? Okay. Let's combine these. All right. One more page of review. Okay. Rewrite this one. You tell me what it looks like. The 8th root of 11 is 11 to the what power? Right? 11 to the 1/8 power? Okay. How about this one? The 12th root of 5 to the 7th power. 5 to the 7/12th, right? Okay. Now, just real quickly, you realize that this is going to be less than 5, right? Because 5 to the 1 power is 5. But 5 to a fraction of 1 that's less than 1 won't quite be 5, right? Okay, just something to think about. Okay, we'll get to that. Okay, this is where the funky looking ones come in. Okay, look at that thing. It's like the square root of 3 times the square root of 3. Ugh. Okay, bizarre. Okay, but we can do something to this to kind of like make it look like those old ones we just saw. So copy that thing down. What we're going to do is we're going to take this part underneath the radical and we're going to make it nice and easy and simple. Okay, we already know, first off, let's just forget the big radical. Forget that thing. Let's look at the 3 and the square root of 3. Let's first look at this, okay? 3, they don't show you anything, but it is 3 to the what power if nothing's written there? 1, right? Okay. This, the square root of 3, is understood to be 3 to the what power? 1/2, right? Okay. Forget all the other stuff. If you had this problem in your Algebra 2 book, and they said, simplify this, you'd go, oh, okay. And if it was over here, if you did x to the 2nd times x to the 5th, you would go, oh, x to the 7th, I got it. Well, that's exactly what you do here, right? 3 to the 1st power times 3 to the 1/2 power, you just add those together, correct? Okay, so you could do a common denominator and go, that's 3 to the 2 halves times 3 to the 1/2. That gives you 3 to the 3 halves, right? Okay, now what we're going to do is we're going to look at this and go, I'm going to rewrite this whole thing, okay? So this is actually what's underneath that radical. So what we have here now, let me include this radical now. So we have this, and that is 3 to the 3/2 power, okay? Anytime you see something, you know, that's taken the square root of, right? Which means that's to the 1/2 power, right? There's nothing here that has a 2 on it. You just understood, you've taken that as a square root, okay? So in other words, this 3 to the 3/2 power, the square root of that, means you're doing 3 to the 3/2 power brought to the what power? If you're taking the square root, that's the same thing as the 1/2 power, right? Okay? We figured this green part out by mashing these together. Then we stuck it under the radical. The radical tells us we're taking the square root of something. By taking the square root, by definition, that's brought to the 1/2 power, so that's exactly what we do. Well, when you have a power to a power, don't forget, you're going to multiply, right? So that's the 3 to the 3/4 power, and that is the answer to this monstrosity right there. Okay. Now good? You can rewind it if you need to. Let's do another one, okay? Blah. Here's another one. It looks kind of similar. All right? Copy it and let's pick it apart. Okay. All right. Our method needs to be, forget all this glop out here. Forget the radical. Totally only go with the stuff under the radical. Let's fix that first. Write both of those as a base and a power. So there's a 3 there with nothing. 3 to the 1st power, right? Done. With this here, the square root of 3, by definition, is 3 to the 1/2 power, right? Okay. Well, if you have x to the 10th times x to the 2nd, your answer is x to the 12th. And if you have 3 to the 1 times 3 to the 1/2, the answer is 3 to the 1 plus 1/2. And again, you can go, do your little 2 halves plus 1/2 is 3 halves. So the answer to this now is 3 to the 3/2 power. Now that is what we want to put here, okay? So let's rewrite this thing with it's actually the cube root of, and then we can just stick this underneath there, right? 3 to the 3/2 power. Okay, all right. Well, if we go back here and we go, by definition, the square root of something means you bring it to the 1/2 power. The cube root of something, by definition, means you bring it to the 1/3 power, right? So we have, our answer is going to be 3 to the 3/2, which is just this number. We're going to bring the entire thing to the 1/3 power. Since this is kind of like having a 1 out there, remember the 1's on the top and 3's on the bottom? That's what we're going to do. And if you look at this, if you forget, you can always just go straight across, you know, and go, okay, that's going to be 3 to the 3 over 6 power, which of course you can just go, that's 3 to the 1/2 power. Or, in other words, the square root of 3. But either one of those is fine. And that's it. Follow your methods. Do under the radical first, then tack on whatever is happening to the outside. Okay? Here's another one. Looks horrible because of all the x's and y's and all that jazz, but it's really not too bad because we're going to do exactly the same thing. Okay, we're going to do exactly the same thing. So let's copy. If you haven't done that already, take a pause there. Okay. All right, well, let's just work with this one first. Do them one at a time here. Okay, well, obviously we have x to the, of course, we understand there's a 2 there, right? Okay, so we have x to the 3/2 power for that one. Then we have y to the, 2 over 2, which is just 2 over 2 is just 1, right? Done. Okay. The second one, you assume there's a 1 above both of those, right? Okay. So this is going to be x to the 1 over 3. And this will also be y to the 1 over 3. And there you go. Okay. The only thing we have to do now is to add these together. We need to get this x together, and we need to get that x together. We already know if we have x to the 5th times x to the 3rd, that's going to be x to the 8th. Well, we do exactly the same thing. We add them. Okay. Common denominator is 6. So we have x to the something over 6, x to the something over 6. This will be 9 over 6. This will be 2 over 6, right? Okay. So we have x to the 11 over 6. Okay. The y is 1 and 1/3. You probably can just do this in your head. 3/3 plus 1/3 is 4/3. And there you go. And that is your final answer. Same old thing you've always done. All you're doing is just rewriting this, as this right here and adding fractions. That's all this is. Okay. All right. Let's take a look at this one. Looks a little more complicated. Take a sec, copy it down. All right. Probably this will be a little faster for you. Let's look at this first term. This will be, of course, x to the 5/3 and then y to the 3/3 or 1. You don't have to write the 1, but we can. Done. All right. The second one will be x to the 1/4 and that'll be y to the 5/4. And just as a quick matter of thing to say, okay, if you go y to the 5/4, that's going to be a little more than y because 5/4 is a little more than 4/4. Y to the 4/4 is the same thing as y to the 1 power. So this will be slightly more than the value of just 1y. Okay. Well, let's get the x's together like this. And all we need to do is just add them together. We just need a common denominator, right? Let's just do it over here. It's 12, right? Something 12 and then something 12. So 3 times 4 and then 5, that'd be 20. And then 4 times 3 and then be 3. So 20 plus 3, so we have x to the 23/12 power. And then y, of course, this will be 4/4. So that'll be 4/4 plus 9/4. And there you go. And that's it for those. Okay. Okay. We have 3 practice set problems. So try each one of those. Go ahead and pause it and try A, and we'll come together in 1 second. Okay. Let's take a look. We have 3, and then we have square root of 7 over square root of 3, and then we rationalize that. And that gives us 3/21 over 3. Wow, that knocks that out nicely. Okay, so we have just the square root of 21 for that one. Okay, the second one, this one, we have 5 square root of 3 over square root of 7. Of course, rationalize the denominator. And we have 5 square root of 21 over 7. All right, that's our second one. 84, you probably recognize, we're looking at, 3s and 7s and all that kind of jazz. But again, if you ever forget, like, oh no, I can't remember which one this is. Oh no, is it the, just go over here somewhere and go 84. And go, I don't know, well, I know it's 2 times 42. So 42 is 2 times 21. you know, you can go, okay, that's 3 times 7. So I got what, 2, 2, 3, and 7? Okay, so that's what you stick under here. 2, 2, 3, and 7. So you go, there's my match, right? So the square root of 4 is 2. Then we have 3 times 7, or 21. So this turns into 2 times the square root of 21. And this is kind of weird because it's just over a 1 again. Okay, anyhow, no big deal. Okay, well, if we have these 3 as our terms, then we have 1 as our denominator. Excuse me, 7 as our denominator. You know, let's just write it out again. Okay, so we have the square root of 21 plus 5 square root of 21 over 7. Let me make sure I did that right. You can pause it, or let's see here, 21, 3. Okay, well, that should be okay. All right, the last one is 2 times the square root of 21. All right, so obviously we're going to have to go with these. We multiply by 7, multiply by 7, multiply by 7, multiply by 7. Okay, so we have 7, 12, and then 14 more, right? So 7, 12, 14 more, so that's 26. Square root of 21, and all of these is over 7. Okay, and 26 and 7 don't reduce, so there's nothing you can do there. Okay. All right, let's take a look at B. So go ahead and pause it and go for B. All right, here is B. We have 2 square root of 3 over the square root of 5. We rationalize by doing this, which gives us 2 square root of 15 over 5. That's one of our terms. The second term, we have 5 square root of 5 over the square root of 3. And we do square root of 3. And we get 5 square root of 15 again, this time over 3. All right. The last term is a square root of 135, which again, you can go, well, I don't know what to do here. 135. Well, I know it's a 5, okay, because it ends in 5. And you did a long division, you'd find out, oh, 27. Okay, well, that's 3 times 9, and then you can go 3 times 3, okay, and here we go. All right, so there's a pair. In other words, this is going to be 3 times 3 times 3 times 5, okay. There's your pair that comes out. That's the square root of 9. That goes out to here to be 3. Okay, so this is going to be 3. And then 3 times 5 is 15, so that's your term right there. So the last term, there's our second one, and our last one is 3 square root of 15. Okay, all right, let me do a tiny bit of erasing here so I can get some room. All right, and the very last thing we'll do is add these all together. So we have, of course, we'll put this over 1, and we'll go 2 square root of 15 over 5 plus 5 square root of 15 over 3, that's a 3, plus 3 square root of 15 over 1, okay? And common denominator, we're going to have to figure that out. That's going to be 15, of course. So times 3 times 3 times 5 times 5 times 15 times 15, right there. So 3 plus 2 is 6, 5 times 5 is 25, 15 times 3 is 45. All these are square root of 15s, so they're like terms. So 6 plus 5, let's just do 25 plus 45. That's 70. 70 plus 6, 76. Square root of 15 over 15. Just such weird numbers. Anyway, that's your answer for that one. Okay? All right, pause it and try C and see what you get. Okay? Make sure you pay attention to the method of this. It's very important. Again, so much stuff we do from now on to the rest of the year is just making weird new stuff look like old stuff so you can do it. All right? So that's what we're going to do here. We're going to forget this outside part. We're just going to work on this little hunk down here. So 7 just sitting there by itself is 7 to the 1 power. The square root of 7 underneath there, by definition, is 7 to the 1/2 power. That's just the way, that by definition, 1/2 power, okay? Now you can do the same thing you would do if you went, you know, a to the 4th times a to the 5th is a to the 9th. You just add them, right? So 1 is just 2 over 2. 2 halves plus 1 half is 3 halves. So this is what you have right there to take this as place right now. Okay, so now let's go ahead and go, okay, well what we're actually doing is find the square root of that. Well, again, you can visualize this if you want to as having a 1 there and just a 2 there, right? I mean, just by definition. Any square root, by definition, is something to the 1/2 power. So if we go, okay, well, it's that thing to the 1/2 power, then that's it to the 1/2 power, right? So if you take a power to a power, you multiply. So 3 times 1, 2 times 2, and there you go. And if you had to write this, if they ever ask you sometime, oh, write this as a number under a radical, okay, fine. Well, 7 to the 3/4 power, all right? There's a 7 to the 3, that 3 there, and then we're taking that, yep, there you go. And they know if they'll ask you that or not, but if you know, if they do, you're ready. So anyway, okay. All right, thanks guys, hope that was helpful.